From the moment people first looked up at the night sky, it was clear that it wasn't just empty space. It was a place of stories, questions, and inspiration. And as we've learned to explore beyond our own world, our understanding of this cosmic neighborhood has grown deeper and richer. So let's take a journey through the solar system and discover what makes each part of it unique. We begin at the heart of it all, the sun, whose radiant light has traveled millions of miles to reach us and shape the worlds that orbit it. From there, we'll drift outwards and examine the rocky planets, the swirling gas giants, and peer into the icy regions where sunlight fades and temperatures drop. Each planet holds clues to our solar system's history, and this evidence is written across their surfaces, atmospheres, and moons. Yet as we travel deeper into space, one truth becomes unmistakable. Among all these worlds, Earth stands alone. Here, liquid water gathers in rivers, lakes, and oceans. Here, a protective magnetic field shields the surface from solar storms. And here, a balanced atmosphere supports forests, coastlines, and life in all kinds of extraordinary forms. Earth is a rare convergence of the right distance from the sun, the right chemical ingredients to support life, and long-term planetary stability, strengthened by the gravitational influence of our unusually large moon. This planet maintains a delicate harmony of conditions that has allowed oceans to form, climates to evolve, and life to thrive for billions of years. At the core of our solar system lies the sun, a blazing sphere of plasma that provides light and warmth necessary for life on Earth. Containing more than 99% of the solar system's total mass, the sun's immense gravity binds the planets, asteroids, and comets in orbit all around it. Its surface churns with convection currents and magnetic storms, and deep within, nuclear fusion transforms hydrogen into helium, releasing energy that sustains our world. Every sunrise is a reminder that we circle a dynamic, powerful star, and one that shapes our world and sustains everything that we know. The first planet from the sun is called Mercury, and it's a small rocky world that is really shaped by extremes. It has a tight orbit around the sun and makes one full revolution every 88 days. There are intense temperature swings on Mercury. There is scorching heat on the day side and bitter cold temperatures on the night side. Mercury's surface is marked by craters, cliffs, and broad volcanic plains. NASA's MESSENGER mission showed that it was once geologically active, and its data offered new views of the planet and its evolution over time. Named for the swift Roman messenger god, Mercury lives up to its reputation by moving quickly across the sky. Because it stays so close to the sun, it's best seen just after sunset or just before sunrise, appearing low on the horizon as a bright yet easy-to-miss point of light. Now we come to Venus, the second planet from the sun, which is similar in size and composition to Earth, but vastly different in every other way. It is the hottest planet in the solar system, even hotter than Mercury, which lies closer to the sun. This intense heat is driven by its thick atmosphere. It has a dense, choking layer of carbon dioxide wrapped in reflective clouds of sulfuric acid and has crushing surface pressures. These clouds trap heat so effectively that a runaway greenhouse effect has taken hold, and this pushes surface temperatures to extremes. The pressure on Venus's surface is more than 90 times greater than the pressure at sea level on Earth. To put that into perspective, standing on Venus would feel like being nearly a kilometer underwater here on Earth. The Venusian landscape is shaped by widespread volcanic plains, ancient lava flows, and towering mountains that have been sculpted by the heat and long-lasting geological activity. For centuries, Venus remained an enigma because its surface was hidden from direct view. That changed in 1982, when the Soviet Venera 13 lander touched down and transmitted the first color images from the surface. Under a heavy orange sky, it revealed fractured rocks and a rugged ground. This provided our first snapshot of a world so extreme that the lander survived for just over 2 hours. Venus has one of the strangest rotations in the solar system. It spins backwards compared to most planets, rotating from east to west in what's called a retrograde motion. Even more unusual, Venus rotates so slowly that a single day on Venus, which is one full spin on its axis, lasts longer than its entire year. While Venus takes about 225 Earth days to orbit the Sun, it needs roughly 243 Earth days to complete one rotation. Scientists think a massive early collision caused this backward rotation, and this likely past event continues to influence the planet's harsh and volatile climate. Today, Venus is once again becoming a focus of exploration. NASA's Da Vinci mission will plunge through the atmosphere, taking detailed measurements of its chemistry and structure, while Veritas will map the surface with high-resolution radar to uncover more of its geologic history. ESA's Envision mission will explore the planet's surface and subsurface, helping scientists to understand how Venus evolved so dramatically different from Earth. All of these missions circle one question: why did Venus and Earth turn out so differently? And understanding this will help us learn how rocky planets and their climates evolve over time. Venus is one of the easiest planets to find in the night sky. It's either just visible after sunset as the evening star, or just before sunrise as the morning star. Venus is the third brightest object in the sky after the sun and moon. Earth is unique among the terrestrial planets. It's the only world with vast oceans of liquid water, a protective magnetic field, and a breathable atmosphere rich in nitrogen and oxygen. These systems all work together to create a stable environment where life can grow, adapt, and persist. The Earth also orbits the Sun at just the right distance for liquid water to exist on its surface, a region often called the Goldilocks zone. It's not too hot, it's not too cold, but just right for water, weather, and life to exist. Earth's 23.5-degree tilt is what gives us the seasons, and it changes the angle of sunlight across the planet as we move around the Sun. The steady rotation of the Earth creates a day and night cycle. This drives winds, weather patterns, and balances the daily rhythm of life. Earth is the outlier when compared to all the other terrestrial planets. Mercury is scorched, Venus is buried underneath a choking atmosphere, and Mars is cold and desert-like. Only Earth has the balance of climate, geology, and life, and we have yet to see anything else like our own planet anywhere else in our solar system and in the universe from what we've explored so far. As we travel beyond Earth, we arrive at Mars, the fourth planet from the Sun, named after the Roman god of war. This cold desert world has drawn human curiosity for centuries and is now one of the most thoroughly studied places in our entire solar system. Half the size of Earth, Mars is known as the red planet. Its color is a result of iron-rich dust coating the surface. Mars is a land of towering volcanoes, immense canyons, and sweeping deserts. Mars has a thin atmosphere of carbon dioxide. This envelope of air is so thin it is not able to hold much heat, so temperatures plunge well below freezing on most days. Still, when analyzing the planet's surface features, the evidence suggests a story of a warmer, wetter past. Dry riverbeds, lake basins, and minerals that form in the presence of water all point to a time when liquid water once flowed across the Martian landscape. The Curiosity rover continues to explore this dry landscape, uncovering evidence that liquid water once flowed here. The Perseverance rover is also making its way across the landscape, giving us clues about Mars' ancient past. The most striking feature of Mars is the towering volcano of Olympus Mons, the largest volcano in the solar system. This mountain is 3 times the height of Mount Everest, which is Earth's highest peak. Next is Valles Marineris, which is a large canyon system that stretches across the planet. It's one of the largest canyon systems ever discovered. These features reveal a planet shaped by powerful geological forces, even though much of that activity has slowed over time. Mars has 2 small moons, Phobos and Deimos. They are named after the Greek personifications of fear and terror, the twin sons of Ares, the god of war, who are said to ride into battle alongside him. These moons are small and irregular in shape, and they are most likely captured remnants left over from the early solar system, and they race quickly around Mars in tight orbits. Despite their differences, Earth and Mars share several important similarities that make Mars especially compelling to study. Both planets have roughly 24-hour days, tilted axes that produce seasons, and surface features that are shaped by volcanism, erosion, and ancient water activity. Mars once had rivers, lakes, and possibly shallow seas, and the evidence suggests that it may have had a thicker atmosphere long ago. These shared traits hint that Mars and Earth may have followed similar paths early in their histories, before diverging dramatically over time. Yet turning Mars into a long-term human home presents enormous challenges. Mars lacks a strong magnetic field, leaving its surface exposed to harmful radiation. Its thin atmosphere offers little protection from surface extremes, micrometeorites, or solar storms, and liquid water cannot freely exist on the surface at the moment. The planet's cold climate, low gravity, and frequent dust storms add further complications. Any permanent settlement requires more advanced technology to provide shelter, breathable air, reliable energy, constant water, and sustainable food, making life on Mars possible, but really, really far from being easy. No world beyond Earth has been explored more thoroughly than Mars. Orbiters map its surface, landers study its soil, and rovers like Curiosity and Perseverance travel across its terrain, searching for clues about past environments and the possibility that Mars may once have supported microbial life. Each mission helps us understand not only Mars's history, but also what makes planets habitable and what might await future explorers. Between the orbits of Mars and Jupiter lies a region filled with rocky debris known as the Asteroid Belt. This region contains millions of objects, from tiny fragments to bodies hundreds of kilometers across, and they all orbit the Sun. These asteroids are left over from the early formation of the solar system about 4.6 billion years ago. As dust and rock began clumping together to form planets, this region might have formed another world as well, but the powerful gravity of nearby Jupiter repeatedly stirred up this material and it prevented it from gathering into a single planet. Today, the asteroid belt holds surprisingly little mass. In fact, if you combined all the asteroids together, they would add up to only a small fraction of the mass of Earth's moon, which is far too little to become a full planet. Movies often show the asteroid belt as a dangerous swarm of tumbling rocks. In Star Wars, C-3PO famously warns that the odds of successfully navigating an asteroid field are 3,720 to 1. In reality, the asteroids are incredibly spread out. If you stood on one asteroid, the next one might be hundreds of thousands to millions of kilometers away. Spacecraft have passed through the belt many times without encountering anything nearby. The largest object in this region is called Ceres, a dwarf planet about 940 kilometers across. It is massive enough for its gravity to pull it into a round shape, and this one alone contains a large portion of the asteroid belt's total mass. When NASA's Dawn spacecraft arrived in 2015, it revealed a surprisingly complex world with water-rich minerals and bright, salty deposits left behind by ancient, briny liquids. These rocky bodies between Mars and Jupiter are time capsules from the earliest days of planet formation, remnants of the building blocks that never quite came together. And just beyond this rocky frontier lies the most massive world in our solar system, Jupiter, the giant whose immense gravity helped shape the asteroid belt in the first place. Beyond the asteroid belt lies Jupiter, the largest planet in our solar system. Named after the Roman king of the gods, Jupiter truly lives up to its name. With a mass more than twice that of all the other planets combined, Jupiter dominates the outer solar system with its immense gravitational influence. Unlike the rocky planets closer to the Sun, Jupiter is a gas giant. It has no solid surface like Earth or Mars, and instead it's made mostly of hydrogen and helium, the same elements that make up the Sun, and they swirl together in enormous bands of colorful clouds that wrap around the planet. These bands are easily seen through a telescope, and they host some of the most powerful storms in the solar system. The most famous is the Great Red Spot, a gigantic storm that has been raging for at least 350 years. This storm is so large that the Earth itself could fit inside of it. Jupiter's immense gravity plays an important role in shaping the solar system. Sometimes described as kind of a cosmic vacuum cleaner, Jupiter can capture or redirect comets and asteroids that might otherwise travel towards the inner planets. While it doesn't stop every object, its gravitational influence likely reduces the number of large impacts that worlds like Earth experience. Another remarkable feature of Jupiter is its vast magnetosphere. which is considered to be the largest structure in the solar system. Extreme pressure turns hydrogen into a metallic fluid, and as Jupiter spins rapidly, this material generates a powerful magnetic field. This magnetic field creates a vast bubble around Jupiter that stretches millions of kilometers into space. The tail of this magnetosphere extends so far that it can even reach beyond the orbit of Saturn. And within this enormous region, charged particles become trapped and are funneled inward towards Jupiter's poles, producing spectacular auroras. Much like Earth's northern and southern lights, these glowing displays occur when energetic particles from the sun collide with gases high up in the planet's atmosphere. Jupiter is also orbited by a vast system of moons, more than 90 known so far, forming its own miniature solar system of its own. 4 of these moons were first observed by Galileo in 1610, and they remain some of the most fascinating worlds we know. These moons are Io, Europa, Ganymede, and Callisto, and each moon tells a different story. Io is the most volcanically active world in the solar system, covered in hundreds of erupting volcanoes powered by the intense gravitational tug-of-war between Jupiter and its neighboring moons. Europa, by contrast, is an icy world that likely hides a vast global ocean underneath its frozen crust. Scientists believe this ocean may contain more water than all of Earth's oceans combined, making Europa one of the most promising places to search for life beyond our planet. Ganymede is the largest moon in the solar system, and it's even bigger than the planet Mercury. It is also unique because it is the only known moon to generate its own magnetic field, suggesting a complex interior with a liquid magnetic core. And then there is Callisto, a dark and heavily cratered world that preserves one of the oldest surfaces in the solar system. Callisto orbits much farther from Jupiter than the other 3 Galilean moons and receives far less radiation. This makes it a much safer place for spacecraft and potentially for future human missions. Exploration of the Jupiter system continues today. NASA's Juno spacecraft is currently studying Jupiter's atmosphere, magnetic field, and deep interior, and new missions are also on the way. The Europa Kuiper spacecraft will closely study the icy moon to investigate whether its hidden ocean could support life. Another mission called Lucy is traveling to visit the Trojan asteroids, which are ancient objects that share Jupiter's orbit around the sun, and these bodies may hold clues about how the giant planets and the rest of the solar system first formed. And as we move farther outward from this giant world, we encounter another iconic planet, Saturn and its famous, magnificent rings. Continuing outward through the solar system, we arrive at Saturn, the 6th planet from the sun and one of the most recognizable worlds in the night sky. Named after the Roman god of agriculture and time, Saturn is famous for its spectacular ring system, the most extensive and complex rings of any planet in our solar system. Although Saturn's rings look like solid bands from a distance, they are actually made of billions of individual pieces of ice and rock orbiting the planet. These particles range in size from tiny grains to chunks as large as mountains. Because the rings are made of separate pieces, you couldn't walk on them like a solid surface. Instead, a spacecraft could actually fly through the rings, weaving between the countless icy fragments that travel together around the planet. And despite stretching hundreds of thousands of kilometers across, the rings are surprisingly thin. In many places, they are only tens of meters thick, thinner than a city skyline is tall. Scientists believe these rings may have formed when a moon or comet wandered too close to Saturn and was torn apart by the planet's powerful gravity, leaving behind the ring system we see today. Much of what we know about Saturn's rings comes from Cassini, a NASA spacecraft that studied the Saturn system from 2004 to 2017. Cassini revealed that small little moonlets and nearby moons shape the rings into gaps and waves, and it also discovered that tiny icy particles are slowly falling from the rings into Saturn's atmosphere in a process called ring rain. During its final orbits, Cassini even flew between Saturn and its inner rings before plunging into the planet's atmosphere. Like Jupiter, Saturn is a gas giant composed mostly of hydrogen and helium. Its low density makes it the least dense planet in the solar system, so light, in fact, that if there were an ocean large enough, Saturn could theoretically float. Saturn is surrounded by an extraordinary system of moons. more than 140 discovered so far, giving it the largest number of known moons of any planet in the solar system. Many of these are fascinating worlds in their own right. The largest is Titan, a moon even bigger than the planet Mercury. And it is especially remarkable because it has a thick atmosphere and an active weather system. But instead of water, Titan's lakes and rivers are filled with liquid methane and ethane, creating this alien version of Earth's water cycle. Another intriguing moon is called Enceladus. It's a small icy world that shoots towering plumes of water vapor and ice particles into space from cracks near its south pole. These geysers suggest a hidden global ocean beneath the surface, making Enceladus one of the most promising places to search for life beyond Earth. Saturn also has another remarkable feature at its north pole, where a massive storm forms a striking six-sided jet stream, creating this giant hexagon thousands of kilometers wide. It was first discovered by the Voyager spacecraft and later studied in detail by Cassini. This geometric storm has persisted for decades and remains one of the most unusual atmospheric structures in the solar system. In 2005, the Huygens probe separated from the Cassini spacecraft and parachuted through Titan's thick atmosphere, becoming the first spacecraft to land in the outer solar system. This was a huge moment for planetary exploration. As it descended, Huygens sent back the first images ever taken from Titan's surface, revealing a landscape shaped by rivers and channels carved not by water, but by liquid methane. Titan is such a fascinating world that it really deserves its own video, which will eventually be coming on this channel. Much of what we know about Saturn today comes from the Cassini spacecraft, one of the most successful planetary missions ever flown. Launched in 1997, Cassini arrived at Saturn in 2004 and spent more than 13 years studying the planet, its rings, and its moons. In 2017, Cassini ended its mission with a dramatic grand finale, diving into Saturn's atmosphere to avoid contaminating moons that may hold the ingredients for life. Next, we arrive at Uranus, the seventh planet from the Sun and the first planet ever discovered with a telescope. It was found in 1781 by astronomer William Herschel, expanding the known size of the solar system for the first time in human history. Uranus is named after the ancient Greek god of the sky, making it the only planet in our solar system that keeps a Greek name rather than a Roman one. And before we go any further, it's worth talking about the planet's name, because Uranus is one of the most misunderstood pronunciations in astronomy. The planet is named after Uranus, the ancient Greek god of the sky and the father of the Titans. In mythology, Uranus represents the heavens themselves, making the name a fitting choice for a newly discovered world beyond Saturn. But when the planet was discovered in 1781 by William Herschel, he proposed naming it Georgium Sidus, or George's Star, in honor of King George III of England. But that name never caught on outside of England, and eventually astronomers adopted the name Uranus, continuing the tradition of naming planets after mythological figures. The correct astronomical pronunciation is usually given as Uranus. However, because of how the word sounds in English, the name has famously been twisted into several humorous variations over time. Astronomers often use the pronunciation Uranus or sometimes Uranus to avoid those unfortunate interpretations. Either way, the name traces back to the ancient Greek word for sky or heaven. In astronomy, there are often multiple accepted pronunciations, and how you say a name can depend on where you're from. So what's the right way to say the seventh planet from the Sun? Ultimately, it's up to you, though I tend to use a pronunciation closer to the original Greek version, mostly because it gets fewer giggles in my classroom and it keeps the focus on the science and how cool this planet really is. And now that we've cleared that up, let's take a closer look at this sideways world. Uranus belongs to a class of planets known as the ice giants. Unlike the gas giants of Jupiter and Saturn, Uranus contains large amounts of water, ammonia, and methane ice mixed with hydrogen and helium. The methane in its atmosphere absorbs red light and reflects blue wavelengths, giving Uranus its soft blue-green color. And the most unusual thing about this planet is its extreme tilt. the planet rotates at an angle of about 98 degrees, meaning it essentially rolls through space on its side. Scientists believe this strange orientation may be the result of a massive collision early in the planet's history. Because of this tilt, Uranus experiences some of the most extreme seasons in the solar system. Each pole spends about 42 years in continuous sunlight, followed by 42 years of darkness as the planet slowly orbits the sun. Uranus is surrounded by a diverse family of 28 known moons, but 5 large ones dominate the system: Miranda, Ariel, Umbriel, Titania, and Oberon. Unlike the moons of most planets, these are named after characters from the plays of William Shakespeare and the poetry of Alexander Pope, giving the Uranium system a literary theme. And each of these moons has its own unique character. Miranda, the smallest of the 5, may have the most dramatic landscape. Its surface looks almost stitched together with enormous cliffs, deep canyons, and strange patchwork regions that hint that the moon may have been shattered and reassembled long ago. Ariel appears younger and brighter than its neighbors, and its surface is carved with valleys and long fault lines, suggesting that internal forces once reshaped the icy crust. Umbriel is darker and more heavily cratered, preserving a surface that has changed very little over the billions of years, and the 2 largest moons, Titania and Oberon, are roughly half the size of Earth's moons. Their surfaces are scarred by ancient impacts and enormous canyon systems, and this offers clues about the early history of this system. Recent studies even suggest that several of these moons, including Ariel, Umbriel, Titania, and Oberon, may hide saltwater oceans beneath their icy shells, and this makes them potential ocean worlds that are deep in the solar system. Together, these moons form this complex system of icy worlds, all orbiting one of the strangest planets in our solar system. And despite its fascinating features, Uranus remains one of the least explored planets. The only spacecraft to visit it was Voyager 2, which flew past the planet in 1986 and provided the images and data that still shape much of our understanding about it today. And as we move even farther from the sun, we reach the outermost major planet in our system, Neptune, a world of deep blue color and supersonic winds. Farthest from the sun among the major planets, we arrive at Neptune, a deep blue world shaped by powerful winds and extreme weather. Discovered in 1846, Neptune was the first planet found through mathematical prediction, which is a major milestone in the history of astronomy. Neptune is an ice giant composed of hydrogen, helium, and large amounts of water, ammonia, and methane. It's the methane that gives this planet its striking blue color. And despite its distance from the sun, Neptune is one of the most dynamic planets in the solar system. It has the fastest winds ever recorded, reaching speeds of over 2,000 kilometers per hour. And these winds drive massive storms, including the Great Dark Spot. This area on Neptune was first seen by Voyager 2 in 1989. However, unlike Jupiter's long-lasting Great Red Spot, Neptune storms are temporary, and the original Great Dark Spot disappeared within a few years, and new storms have formed and faded since then. Neptune is orbited by 14 known moons, and the largest, Triton, is one of the most unusual worlds in the solar system. It orbits in the opposite direction of Neptune's rotation, and this suggests that it was likely captured from the Kuiper Belt rather than forming alongside the planet. This moon is also incredibly cold, with surface temperatures nearing negative 235 degrees Celsius, and this makes it one of the coldest known objects in the solar system. Yet despite this, it is geologically active. Voyager 2 observed towering plumes of nitrogen gas erupting from its surface, and this is a form of cryovolcanism, where ice and gas replace molten rock. Triton's surface looks relatively young, with fewer craters than expected, and this is a sign that internal activity may still be reshaping the moon. Scientists even think that it may have a hidden ocean beneath its surface, making it an interesting place to look for conditions that could support life. Neptune remains one of the least explored planets. The only spacecraft to visit it was Voyager 2, which flew past in 1989 and gave us our only close-up view of this distant ice giant. And since that flyby, telescopes like Hubble and the James Webb Space Telescope have continued to study Neptune from afar. And these observations reveal that its atmosphere is constantly changing. It has storms that form and fade just over a few years. And the infrared views that are coming out of JWST have also highlighted bright methane ice clouds, a distinct polar vortex, and faint rings that are very difficult to detect in visible light. And this shows that even at the edge of the solar system, Neptune remains an active and evolving world. And beyond Neptune lies the outer frontier of the solar system. Beyond Neptune, we arrive at one of the most familiar and most debated worlds in our solar system, the dwarf planet Pluto. It's hard to talk about Pluto without mentioning its reclassification. For decades, Pluto was known as the ninth planet, a small, distant member of our planetary family. But in 2006, astronomers redefined what it means to be a planet. To qualify, a body must orbit the sun, it must be round, and it must clear its orbit of other debris. Pluto meets the first two criteria, but not the third. It shares its region with many other icy objects in the Kuiper Belt, and because of this, Pluto is reclassified as a dwarf planet. For some, that change felt like a loss, but in reality, it marked a deeper understanding of our solar system, revealing that Pluto is a part of a much larger population of distant worlds. Since its discovery in 1930, Pluto remained little more than a distant point of light, until 2015, when NASA's New Horizons spacecraft gave us our first close-up view, and what it revealed was a world full of surprising complexity. One of the most striking features is a vast, heart-shaped region called Sputnik Planitia, a plain of nitrogen ice so smooth and young that it contains almost no impact craters. This suggests that Pluto is still geologically active, even at the edge of the solar system. New Horizons also discovered towering mountains made of water ice, and they rise several kilometers high. At Pluto's extremely low temperatures, this ice behaves like solid rock, and it forms the foundation of its landscape. The surface also shows signs of glaciers slowly flowing and reshaping the terrain over time. Above it all, Pluto has a thin atmosphere that forms delicate layers of blue haze that softly glow when backlit by the sun. Pluto's largest moon, Charon, is so large compared to Pluto that the two bodies orbit a shared center of gravity. Together, they form a kind of binary system, which is unlike anything else that we see among the planets in our solar system. The New Horizons spacecraft transformed Pluto from this distant curiosity into a complex and evolving world, and one that challenges a lot of our assumptions about what a small icy body can have on its surface and how it behaves. And Pluto is not alone. It's just one of the many objects in this vast region beyond Neptune. And this distant frontier is filled with many icy remnants from our early solar system. And this area is known as the Kuiper Belt. This vast region beyond Neptune is filled with icy remnants from the early solar system. And it stretches billions of kilometers into space and contains thousands of known objects, along with many more that have yet to be discovered. These bodies are mostly made of ice and rock, and they are preserved in the cold outer reaches of the solar system. Pluto is one of the largest members of this region, but it is far from alone. The other dwarf planets in this region, such as Eris, Haumea, and Makemake, orbit the sun here as well, each with its own unique characteristics. Haumea spins so quickly that it has an elongated shape. Eris is slightly smaller than Pluto but more massive, and Makemake is a bright, icy world with a very thin atmosphere that can freeze and collapse onto its surface as it moves farther from the sun. And the discovery of these worlds show that Pluto is just a part of a much larger population of distant objects, and this is helping astronomers better understand the structure of our own solar system. And unlike the Asteroid Belt, which is relatively narrow, the Kuiper Belt is much larger and more spread out, and it forms this distant boundary to the main planetary system. It is also a source of many short-period comets, which are occasionally nudged inward towards the sun. The Kuiper Belt acts like this massive cosmic archive, and it preserves material from the formation of the solar system over 4.5 billion years ago, and it offers clues about how the planets came to be. And far beyond the Kuiper Belt lies an even more distant and mysterious region known as the Oort Cloud. Unlike the flat disk of planets and the Kuiper Belt, the Oort Cloud is thought to form a vast spherical shell that surrounds our solar system, and it extends tens of thousands of astronomical units from the Sun, and it's nearly halfway to the nearest star of Alpha Centauri. This region is believed to be the source of long-period comets, and these icy objects can take thousands or even millions of years to complete a single orbit around the Sun. The Oort cloud has never been directly observed. It's too distant and too faint to see with our current technology. Instead, its existence is inferred from the path of comets that occasionally travel into the inner solar system. These objects are remnants from the earliest days of planet formation and the material that was scattered outward by the gravitational influence of the giant planets from long ago. In a sense, the Oort cloud represents the outermost boundary of our solar system. It has a distant reservoir of icy bodies that mark the edge of the sun's influence. And beyond that boundary lies interstellar space. We've traveled across our solar system, from the intense heat of the sun, past rocky worlds like Mercury, Venus, Earth, and Mars, through the asteroid belt, into the giant planets like Jupiter and Saturn, and out to the distant ice giants and the icy frontier beyond. Each world is different. Some are scorched, some are frozen, some are storm-filled or airless, and some may even hold hidden oceans beneath their surfaces. But among all of them, one world stands apart: Earth. Here, liquid water exists on the surface. A stable atmosphere protects and sustains life. A magnetic field shields the planet from harmful radiation. And over billions of years, geology, climate, and life itself have worked together to create a balanced and ever-changing system. Earth is not just another planet in the solar system. It is a rare combination of distance, chemistry, and long-term stability that has allowed life to take hold and thrive. And yet, from space, Earth looks different. A thin blue line of atmosphere, clouds drifting over oceans. No borders, no divisions, just one small, fragile world suspended in the vastness of space. And when we look up at the sky, we're not just seeing distant worlds, we're seeing our own more clearly. Thank you so much for watching, and keep looking up.